Pay close attention to the massive iron cauldron in front of you. As it tips outward, a bright, orange-red liquid resembling volcanic lava pours out instantly. This liquid mixes slag-free fuel or solvent and other substances generated during the steel mill's smelting process at extremely high temperatures. The temperature can reach 2,000 degrees Celsius, several hundred degrees hotter than volcanic lava. You can almost feel the heat radiating from it, even through the screen. During the smelting process, slag is produced. This slag contains metals and minerals with high recycling value. Many steel mills have dedicated slag cooling pits to receive and cool the slag, facilitating subsequent processing and transportation. Due to the extremely high temperature of the slag, special vehicles, such as slag pot carriers or rail transport vehicles, must be used. The inner walls of these vehicles' containers are typically made of high-temperature, corrosion-resistant materials that can withstand temperatures exceeding 1,500 degrees Celsius. The slag containers are designed for tilted discharge, allowing the slag to pour out as the container is raised naturally. Even though rail transport is used to move the slag, time is of the essence. If the liquid slag cools and solidifies inside the container, it will stick to the walls, making removal difficult. In such cases, a large iron ball is used to knock on the container, breaking the slag free. Open-air cooling pits must be strictly managed. Slag cannot be poured into pits containing water. When high-temperature slag meets water, the water rapidly converts to steam, expanding to 1,700 times its original volume. If the steam cannot escape quickly, it creates immense pressure within the slag, causing it to explode and scatter violently, just like this. Pouring slag is undoubtedly a dangerous job. Now that we've learned about slag, let's examine the entire process of smelting or to produce steel. The black, blocky material in the video is coal, and the glowing parts on either side are ovens. After dehydration and degassing, coal produces tar at 300 degrees Celsius. As the temperature increases to 1,000 degrees Celsius, the coal becomes concentrated and refined into coke for steelmaking. Coke is a refined coal product that removes water, coal gas, and tar, leaving only the essential material for steelmaking. Meanwhile, sintered or is crushed and shaped before being sent to the blast furnace. A reducing gas, typically carbon monoxide, is injected into the furnace. This step is the most dangerous, as blast furnace explosions have caused injuries worldwide. As molten iron forms, its color and consistency make it look like a perfect stew, though it's incredibly challenging to transport. As the molten iron is transferred, impurities float to the surface. These impurities, which weaken steel's structural stability, are removed using robotic arms, leaving only the pure molten iron. The removed impurities are not wasted, but used to build road foundations. Afterward, the molten iron is reintroduced into the furnace for secondary refining, completing the smelting process. Next, we move to step 2, manufacturing rebar. When the ladle arrives beneath the electric furnace, molten iron is continuously poured in from above until the stove is complete. The molten iron flows through a round opening onto a turntable for casting. Precise alignment ensures the molten iron flows steadily, with slight vibrations aiding the formation of steel billets. These billets are then slowly drawn out from below. In another workshop, a cutting device uniformly slices the steel billets to predetermined sizes, ensuring consistent dimensions. However, these billets aren't yet ready for rebar production. They must first cool completely. After cooling, the still glowing hot billets are rapidly transported forward for their first round of rolling. Oxide scales on the surface are thoroughly removed, and the billets are clamped and rolled by top rollers. Through multiple rounds of rolling, the billets double in length. Next, the billets move forward for drawing, a process handled by a production line with dozens of machines. Each pass through the line reduces the billet's diameter until it reaches the desired size for rebar. The final machine shapes and straightens the rebar. After straightening, The rebar drops continuously from the line. The rebar can also be formed into standard circular shapes, making the process surprisingly satisfying to watch. Lastly, the rebar undergoes a cooling procedure. One billet can typically be stretched into a roll of rebar.